Okay, so we're fixing to do 4-1 and 4-2, all right? Some of this stuff you've heard of before, but maybe we're looking at it in a different way, okay? So talk to me, participate, and let me know what you got. All right, so here we go. 4-1. We are going to graph quadratic functions in standard form. Okay, graph quadratic functions in standard form. All right, do y'all know what standard form is?
Yeah.
Do y'all know what standard form is?
Yeah. Yes.
Any, someone want to give me a shot what standard form is?
5x plus 2y equals whatever, right?
Ax plus by equals c.
Okay, all right, that's standard form, but that's for a linear equation. So this is a quadratic. So first of all, to be a quadratic, what do you know it has to have? No, come on. Quadratic.
Square root, right?
Yeah, no, not square root. Square. Yeah, to be a quadratic, it has to have an x squared, okay? So standard form for an x, for a quadratic is gonna be ax squared plus bx plus c. And normally you say equals 0, okay? But because we're graphing, what can I replace legally? What can I replace 0 with? Does anybody, do y'all know? You can replace 0 with y, okay? You can replace 0 with a y. So this is what it's gonna look like. Y is equal to ax squared plus bx plus c. So let's take just a second and talk about our parent function. Now you should know this, right? Because we had a memory test on this. Do you remember? The parent function. What is the parent function? F of x is equal to, or a quadratic?
X squared?
Yeah, x squared, okay? And when you graphed it, what did it look like?
Was it?
Yes? Yes, you made the shape. A parabola, very good. A parabola. And it looked just like this. Do you agree?
Yes, ma'am.
Okay, and that was really all you had to draw. All right, so there are some things that we're going to talk about. So the first thing is this little point that on our parent function is at the origin 0, 0. This is called our vertex. Okay, these are vertex. Now y'all listen to me. I'm just going to give you a quick overview because this is not. I mean, we're going to study this at the end of the year, but I'm not taking a lot of time, especially since I ran out of time last period. So the parabola is part of the 4 conic sections, okay? There are 4 conic sections. They are parabolas, hyperbolas, which you've never heard of, circles, and ellipses. And an ellipse is just like an oval kind of, okay? All right, so those are the 4 conic sections. They call them conic sections because you get them from taking a cone, all right, and slicing it. When you slice it, then you can make all 4 of those conic sections. So that's why they call them conic. Leave a little place right here. Conic sections. All right? You don't have to know that because we're going to study that later in the year. But I'm fixing to tell you something that you're going to think is really strange. All right? And so I tell you all that just to say that on a conic section, this vertex is called HK. It's just what it's called. It's what someone decided. If it were a circle, it would be the center of the circle would be HK. If it were an ellipse, which is like an oval, a squished out kind of circle, the center would be HK. So on a parabola, my vertex, this point right here, is going to be HK. Now, there's also a line, and it goes through the vertex, okay? And it is called the Axis of Symmetry. Does symmetry have 2 M's? It looks kind of funny, doesn't it? It may only have 1. Sorry, I'm not a speller. All right, so an axis of symmetry. Now, obviously, guys, it is going through the vertex, but what kind of line is this right here? A vertical line. How do you write the equation for a vertical line?
X.
Very good. X equals, which looks like 4 V's all stuck together, right? So X is equal to. Now, what does X have to be equal to in order for it to run through this vertex? Okay, but I'm going to move this. This is a parent function. I'm going to move this all over the place on my coordinate plane. But what would X always have to be equal to? Just what? H. Yeah. X is, that's the X value. That H is actually the X value of your vertex, and the K is the Y value of your vertex. Okay? So if I'm talking about a vertical line, it's going to run X is equal to H. Now, here's the deal with this right here. I'm going to make a big deal out of it. You must have this X is equal to. Okay? You must have the X is equal to. Because it is not a number. Is this a number? No, this is a line, people. You got to write it as a line. You can't just say it's 0 or it's 4, -2. No, it has to be X is equal to that in order to make it a line. It is the axis of symmetry, so if you folded your graph on this axis, this line, then this side of your parabola would land on this side of your parabola. We're going to use this to graph our parabola. It's going to make it nice for us. Okay? All right, so here we go. We're going to start off kind of easy. I'm going to start off and I'm just going to talk about an equation that looks like this. Y is equal to ax squared plus c. Now, look at this and look at this and tell me what I did. What did I leave out? B. Okay, so B, probably in the whole scheme of things, B is the most difficult term to talk about. All right, I can tell you exactly what A does to your graph, and I can tell you exactly what C does to your graph. But to talk about B involves a whole lot of stuff. We used to talk about it in Algebra 2 a long time ago, but then we kind of switched our little focus and we started talking about different stuff, okay? So we don't really talk about it so much, but A and C are really easy to talk about. So I'm going to take the B out for a minute and then we'll put it back, okay? So first of all, let's just talk about A. Now you already know stuff about A. All right, you already know stuff about A. You know that if A is positive, which way does my graph open? Up. Okay? If A is negative, which way does my graph open? Down. All right? You know that. This is called the quadratic term, okay? If the quadratic term is positive, then you're going to have a graph that opens up. If your quadratic term is negative, then your parabola is going to open down. All right, so the next thing I want to do is I only want to talk about A. I don't want to talk about his sign because I've already talked about it. I've said, hey, if the sign is positive, it goes up. If it's negative, it goes down. So now I just want to talk about just the number. So what I'm going to do is I'm going to take the absolute value of it. And that takes its sign off of it, and I'm not talking about it anymore. Okay? So if the absolute value of A, if this number, disregarding his sign, if this number is greater than 1, so if this was like a 2x squared or a 5x squared or something like that, all right, tell me, would my parabola be wider, narrower, or the same as the parent function? If this number in front of this x squared is bigger than 1.
Small.
It's narrower. It is narrower. Okay? So you can think about it. Look, I mean, I'm going to write the stuff down right here, but guys, listen to me. Rather than trying to memorize stuff, understand things. If I make this number in front of this x squared bigger than 1,
It's going to be.
pardon me, it's like a vertical stretch, okay? It's bigger than 1, so it stretched it. If you stretch something, do you make it narrower or wider? Narrower. If you stretched me, I would get narrower, right? If you compressed me,
You get bigger.
I'm going to get wider, okay? So that's that's what's gonna happen. So if you have a number that's bigger than 1, my graph is gonna be narrower. Now, does that make sense to you? Because trying to memorize stuff like this is kind of crazy. But if you kind of go, okay, well, if you put a number bigger than 1, that stretched my parabola and it made him narrower. If that A is less than 1, but we're going to make him greater than 0 because we're really not talking about a sign, okay? If he's between 0 and 1, then what does that do? See, that's a compression. And if you vertically compress something, what's it going to do to this graph?
Get wider?
Yeah, he's going to get wider. So, and if the absolute value of A is equal to 1, what's he going to do? Yeah, he's going to stay the same. He stays just the same. Okay, so now let's talk about C. Now you know about C too, guys. Okay, this is just a number out here, right? Just a number. So if C is positive, all right, he's going to move up C units. If it's plus 2, he's going to go up 2. What about if he's negative? What's he going to do?
Go down.
Yeah, he's going to go down C units. So if it's minus 4, he's going to drop down 4 units. So if I took this parabola right here and I said x squared plus 3, what's the only thing it would do to that?
Go down, up 3.
Yeah, if I said plus 3, he's going to go up 3. What if I said minus 5? What's he going to do?
Go down.
Down 5. What if I put a 2 in front of that x squared? What's that going to do to this parabola? Yeah, he's going to stretch him. So is he going to be wider, narrower, or the same?
Narrower.
Yeah, he's just going to make him narrower. It's going to be skinnier. Okay? What if I put a 1/4 in front of that?
It's gonna be wider.
Yeah, he's going to make him go like this. Okay? What if I put a negative 1/4?
Stays the same. No.
It's gonna
I'll go down.
Yeah, he's still going to be wider, but he's going to open down. Okay? So that's what A and C do to it. That's not really that hard. We're going to work a couple of them, and then we're going to move on to putting a B in there, because that's where the problem's going to come in. All right, so y is equal to 1/2 x squared plus 2. So we're going to talk about it, and we're going to graph it. Now, right now, we're just kind of sketching some graphs. We're not really graphing as exact as I'm going to require you to graph. So I'm just going to make me a little graph right here. Okay? And I'm going to ask you some questions. Now, the questions I ask you are the same questions they're going to ask you on the worksheet, which means they're going to ask you where? On the test. Okay? It may not look exactly like it does on the worksheet. Like on the worksheet, it's going to look like what I'm fixing to do right now. But on the test, it just might be a question. It might say, is this parabola, does that 1/2 make a vertical stretch or a vertical compression? You know, you see what I'm saying? All right. So my first question is, the direction that this parabola opens, is it up or down?
Up.
Why?
Because it's positive.
Very good. It's a positive quadratic term. It's a positive a positive x squared. Okay? My next question, is it wider, narrower, or the same as the parent function?
Wider.
Why?
Because it's less than 1.
Very good. Very good. Does everybody understand that? And y'all look, that's most of the time what your brain's going. It's less than 1. Now we know it has to be between 0 and 1. Okay? But, because you know, you wouldn't put something like -4 and then say, well, he's less than 1. Yeah, he is, but we're not talking about the negative sign. You see what I'm saying? Okay, so that's why this other part's up there. All right, so does anybody know, what does that plus 2 do to that parabola that was originally right here?
It goes up 2 units.
Okay, so what's his vertex?
2.
0, 2.
Okay, very good. 0, 2. Remember that it's a point, okay? It's not just a number, it's a point on a coordinate plane, but it did go up 2 units. All right, so now he's up 2 and he is right here. Do you agree?
Yes, ma'am.
Now, I know that he's opening up and I know that he's wider, so he's going to look something like this, okay? But I'm going to pick a point gonna show you something, okay? Now, I could pick any point that I wanted to, but I'm not gonna pick 1 because it makes a fraction, and I don't wanna play with them right now. I'm gonna pick 2, okay? And x is 2. How do I find out what y is? Yeah, you plug it in this equation, and he says y is equal to 1/2 x squared plus 2. All right, what's 2 squared? 4. What's half of 4?
2.
And 2 plus 2?
4.
So at 2, he goes up to 4. Are you with me? Okay, now watch this. What's the axis of symmetry?
It copies, it goes, yeah, it's on the same side. Like,
What is the axis of symmetry?
The
X
y.
equals
Oh, x equals what?
H.
Or,
Well, it's.
what is h?
1/2?
Whoa.
I mean 2. It's, 0. Oh my gosh.
0. Remember, this is h and k. Okay? If you wanted to go through this vertex right here, people, x has to be 0. X equals 2 would pull him over here. Okay? So he has to go through there. That's why the x value has to be equal to this x value. All right? So x is equal to 0. What's going to be the common mistake? To just slap a 0 down on your paper. I'm going to mark it wrong every time you do. Okay? And on every question, they're asking you this. So that would be every question, every one would have something marked wrong. So be careful. All right. So this is my axis of symmetry. Now watch, I'm going to show you how we're going to use this axis of symmetry. I'm going to use this axis of symmetry, and I'm going to reflect this point through it, and it's going to give me a point on this side, and then I can draw it really easy. So I got 2 to get to the axis, and 2 to get away. This is what my parabola looks like. Anybody got a question? Everybody okay? All right, this isn't bad, is it? Okay, so let's look at this. Y is equal to -2x squared minus 4. Let's do this one really quick. All right, I'll draw me a little graph over here. We're just kind of sketching. We're not really being extremely precise. On your worksheet and your test, I'm going to require you to be a little more precise, okay? All right, are you ready? Okay, so first question. Does my parabola open up or down?
Down.
How do you know?
Because it's a negative.
Very good. Yeah, it's a negative quadratic term. A negative x squared, negative 2x squared to be exact. Is he wider, narrower, or the same?
Narrower.
Narrower. Okay, why is he narrower?
Because it's bigger than 1.
It's bigger than 1. This A right here is bigger than 1. If he's bigger than 1, he's a vertical stretch. And if I stretch something like this, it makes it skinnier. Okay? Like if somebody stretched me and made me tall, please do. Okay? Then I would be skinnier, right? All right, so tell me what my vertex is.
Negative.
Be careful doing that, guys.
It's 0, -4.
It's 0, -4. It took that parent function and dropped him down 4 units. 1, 2, 3, 4. But it is a point. You can't just say my vertex is -4. What does that mean? Okay? It's a point. So 0, -4. The B is what's going to move it left or right. But the problem with B is, it seems like that if C moves it up or down, that B would move it that many left or right. It doesn't. It does somehow do the opposite, and we're going to talk about that, but it's not that number. You have to do all kinds of math stuff to it, and we're not going to really do that. So we're going to learn it a different way. All right, what about my axis of symmetry?
X equals 0.
X equals 0. Very good. Okay, so here's my axis of symmetry. Okay, I could pick any point that I want. There's not any fractions for me to think about, so I'm just going to pick 1. All right, I'll tell you this, that the bigger this A gets, okay, then the steeper this thing is going to be, so the faster it's either going to drop or go up, so that you're going to have to hang around that vertex, or you're going to be off your graph. If you get off the graph, it's not really that big a deal. Like if I had to plot the point 1, -15, then I would just go 1, and I'd go, oh, I don't know, right here, and then I'd say 1, -15, Miss Davis. You see what I'm saying? You don't have to make 15 marks, because then you might be off your paper. but you could just do it like that. All right, so I am gonna pick 1, I'm gonna plug it in. What's 1 squared? 1. What's 1 times negative 2? Negative 2 minus 4? Negative 2 minus 4. Yeah, negative 6. All right, so at 1, it's negative 6. Now what am I gonna do at that point? Yeah, I'm gonna reflect it through. I'm gonna go 1 to get to the axis and 1 to get away.
Okay, so you can, doesn't matter what number you pick, like,
No.
so you pick 1.
That's right. You could have picked 2, but watch what happens with 2, okay? And this is what I'm talking about. The farther you get away from the vertex, if this number is really big, he's gonna make that y value really big, okay? Because if I picked 2, watch what happens. I picked 2. 2 squared is 4, right? 4 times negative 2 is negative 8. Negative 8 and negative 4 is negative 12. Well, that was off where I graphed, but
Okay,
you
so
could do
that's-
it.
okay,
You
that's
see what I'm
what you're
saying?
talking about. Yes,
So I kind of hung around. Now, actually, you'll get a better gist of what your graph is the farther away from the vertex that you can go. But a lot of times I'm restricted on how far away I can go. All right? Okay, so everybody okay if I take the B out? Y'all good? Okay, so now let's put the B back in. All right, so this is going to be the most difficult. Now, if I only taught you this way, would you still know all of this right here? Yeah, you sure would. You sure would. But this kind of gives you an understanding, because this tells you that A and C are really important to me. Okay? B, he's going to play a part, but his part is not blatant like A and C are. Okay, so here we go. Y is equal to ax squared plus bx plus c. Okay? Now, my vertex. Remember I told you your vertex is HK. Are you with me? So, I know this B is going to move this thing left or right, so I can't just move it up or down the C units. I'm going to have to play with this guy. So he's going to have an effect on my vertex. So you're going to have to memorize the formula, okay? So we're going to find H, and here is the formula. H is equal to negative B. That's that negative that you were talking about, Juliana. You see what I'm saying? Because he's doing the opposite, and that's what you said. Oh, he's going to do the opposite. Yes, he is. And that's that negative. Negative B over 2A. All right? And once you do that, then you're going to have the H value. How am I going to find K?
K.
Yeah. I'm just going to plug H in. I'm going to plug it in this equation up here, and he's going to tell me the K, which is the Y value of my vertex. Because H is my X value of the vertex. All right? On everything that you do, and you're given like this, you're going to must graph 5 points. Okay? So when it's in standard form like this, you're going to have to find me 5 points. It sounds like a lot, but I'm going to show you it's not going to be as bad as you think it's going to be. Okay? All right, so let's try one. Are you ready? Example 3. Y is equal to 2x squared minus 8x plus 6. Now, am I going to start with the hardest one? No. How can I make these problems more difficult?
Bigger word,
Put what kind of numbers in there?
harder numbers.
Fractions. Okay? So that's what's going to happen on your worksheet. Some of them are going to be fractions. Matter of fact, one of them is going to be the craziest problem that you've ever seen. You're going to be like, why would she do that? I don't know, people. I just put the thing on there and I didn't even work it out until after I put it on there. And then the kids were like, whoa, Miss Davis. One more thing. You cannot use a calculator on this test.
Whoa.
Yeah, no calculators on this test. And after I do this problem and show you something, you will understand why. Okay? Because the calculator's not going to show me what you know. The calculator's going to show me what you can find on a calculator. And that's not really all I'm looking for. So, I'm going to draw me a graph here. T-chart, because obviously, I need a T-chart to support my graph. A T-chart is what always supports your graph. That's what tells the teacher that, hey, I didn't use a calculator and try to trace or copy this off of a calculator. I have my T-chart, and those points support where my graph is, okay? We'll talk about how many you need on your T-chart in just a minute, but it has to do with this right here, okay? So first, let's ask all the questions. Are you ready?
Yes.
Okay, so my first question is, does this parabola, this one right here, does this parabola open up or down? Very good. All right, my second question, you know what it is, guys? Is it wider, narrower, or the same as the parent function? Why? Very good. 2 is greater than 1, and so that makes the vertical stretch that's narrower. Okay? My next question is vertex. What is my vertex? Well, can I look at it and shout the vertex out? No, this B guy's messing me all up, okay? So we're gonna have to use our formula. Now look, whenever you do this, on your worksheet, just like on this piece of paper right here, I'm gonna wanna see some work out here to the side, okay? H is equal to. Until I knew that formula, I would write it every time I used it, okay? And I'm talking about know it like if a tiger's chasing you, okay? So if we put some pressure on you and stress you, can you still recall the formula? What is the formula?
Negative
B over 2A.
Very good. Negative B over 2A. So what is B in this equation?
Negative 8.
Negative 8. So what is the opposite of B? 8. Over 2 times what's A? 2. So that's 8 over 4. What is that?
4. I mean, what?
2. Yeah. 2. Is everybody with me? Does anybody have a question?
Oh, I do have a question actually.
Ask me.
Why do we change, this is stupid, but why do we change it to, why can't it be negative 8 above the 2A? Like in the formula when we plug-
Because it's negative B, it's the opposite of B over 2A.
Oh,
And the
okay.
opposite of negative 8 is a positive 8,
Okay,
okay?
yes ma'am.
If this had been plus 8x,
And
it
then
would
it
have
would
been
be-
negative 8.
Okay, yeah, that makes
All right?
sense.
Okay, so now how am I gonna find K? I'm just gonna plug this guy in. So I'm gonna say 2 times 2 squared minus 8 times 2 plus 6. All right, what do you have to do first?
Square.
Square it. So what's 2 squared?
4.
What's 4 times 2?
8.
Minus, what's 8 times 2? 16 plus 6. What's 8 and 6? Minus 16,
It's 2, negative 2.
negative 2. So 2, negative 2 is my vertex. Are you with me? I'm going to go over here and graph it. 2, negative 2 is my vertex. What's my axis of symmetry? Very good. And I love the x equals. Y'all listen to me. If you don't write the x equals, I'm marking it wrong. It is not a number, okay? It's a line. So x is equal to 2. It's all what y'all, x is, if it has to go through the vertex, then it's gonna be what the x value of the vertex is. So here is my axis of symmetry. Now watch how useful this axis of symmetry is, okay?
Oh, I think I just
So now I need 4 more points. Do you agree? But if I find 2 on one side,
Start calling them out.
can't I reflect it through and get 2 on the other side? You see what I'm saying? So that'll be my 5 points. And I haven't even worked that hard. Okay, now can I pick any x that I want to? Do you agree with that? Okay, I'm gonna tell you what I'm always gonna pick, because y'all, I'm gonna do it the easiest way I can. Okay? I'm always gonna go back to the origin. Those are gonna keep my numbers small. Alright? Could I pick 3 and 4? Yes, you could. But why would you when you can pick 1 and 0? Okay? Why would I pick 3 and 4 when I can pick 1 and 0? Alright? So I'm gonna pick 0 and 1. Let's plug 0 in. Alright? Look, here's my x. Now let's find the y. So I'll plug it in. What is, that's 2 times 0. What happens to that point? What happens to that term?
becomes 0.
What happens to the 8x? What are you left with?
6.
a nice thing to know.
Is that the vertex?
No,
Intercept.
it's my y-intercept. Here's my vertex, 2, -2. Now watch what I'm gonna do. I'm gonna reflect it through my axis of symmetry. So I'm gonna say 2 to get to the axis and 2 to get away. So if you had used the points 3 and 4, 4 would have given you what? 6. Okay? All right, let's do 1. Well, that's 2 times 1 squared minus 8 times 1 plus 6. What's 1 squared? 1 times 2 is -8 times 1 is -8 plus 6. What's 2 and 6? What's 8 minus 8? Oh. So at 1 is 0. And then what am I going to do? I'm going to use it to plot that other point because see, I asked for 5, so this is going to give me all 5 of those points. And this is what my graph looks like.
That's steep.
Okay? It is steep because it's got that 2 and it makes him narrower. Just think about if you'd put a 4 in there. Do you see what would happen? Y'all, if you put a 4 in there, even if I hung around the vertex and I put that 0 in there, he's still going to be way, way up here. Okay? Probably off your graph. All right. Is this everything that I've asked for?
Yep.
Yeah. Direction, wider, narrower, the same. Vertex, axis of symmetry, 5 points supporting my graph.
So your table only has to have 2 points?
Because what am I doing with those 2 points? Reflecting them and getting 2 more points. So these 2 points give me 4 points, and then my vertex gives me the 5th point. Anybody got a question? Okay, so let me show you why I'm not letting you use a calculator. Okay? Oh, and I'm going to tell you one more thing too. I'm going to reflect through my axis of symmetry unless my axis of symmetry ends up crazy like 1 7/16. If I end up with a 1 7/16, am I going to reflect through that? People, I'm not. I'm picking 2 on the left and 2 on the right and moving on. Okay? So if it's 1 1/2 or something like that, then you probably can reflect through that. But anything other than 1/2, maybe a 1/4, some of you can, but I'd say if you're not really good at fractions, just plug your numbers in and get 2 on the left and 2 on the right. Okay, so let me show you why I don't want you to use a calculator. Now, did I say you can't use a calculator to check your work?
No.
I did not say that. Okay, so if you are at home and you're not here in class and you don't have someone, I mean, back in the day, people, we weren't connected at the hip to all our friends like you are. Okay, I mean, you'd have to go to the front of the house or your parents' bedroom and pick up the telephone and call somebody. If they were on a party line, you might not even get them, right? So y'all are different, but I could just check all mine on the calculator. So I'm going to plug it in. 2x squared minus 8x plus 6. Okay? I'm going to go zoom 6, which is a standard 10 by 10 graph, which is normally on a test, that's what you're looking at. Okay? So I'm going to go zoom 6. I look at the graph and I go, well, look at there. That looks pretty much what mine looks like. Okay, so I want to know, is my vertex right? Because my vertex is obviously one of my answers. Okay, so I have 2, -2. So let's see if it's right. Now, would this point right here be a maximum or a minimum? Minimum, right? The lowest that it goes, that's a minimum. All right, so I'm going to go second and calculate. All right, second and calculate. And there's my minimum. Notice that it has maximum. In order for it to be a maximum, which way does your parabola have to do?
Open down.
Yeah, it has to open down, and that would make that vertex a maximum. Okay, we're going to write that down in just a minute. All right, so I'm going to choose number 3. Okay, now notice what's happening. Here's why it's doing this. It's saying, hey, lady, give me some boundaries, okay? Because if, let's say that I graphed an equation and it looked like this. Okay, then this has really, it has these 2, they're called relative minimums, okay? Because this is a minimum relative to this area, and this is a minimum relative to this area. And so, in order to find both of them, which they're both very important when you're graphing, then you would to make some boundaries. If you just told him to find the minimum, he would only find this one, right? Okay, so we would want both of those. So this, we only have one here, so it's not that big a deal. So all he's doing is saying, hey lady, find me a left bound. Well, okay, I just want to be left of the vertex. Now, this is one of those newfangled fancy calculators. It's not quite as pixelated as the ones we use in the classroom. And the ones we use in the classroom, a lot of times they will have like a flat place where the vertex is. Stay away from there, okay? It's not how close can I get to the vertex. Heck, I could press enter right here and say, there you go, there's your left bound, enter. Look what it does. It shoots a line and it says, hey, here's your left bound. Y'all shoots an arrow. The fancy ones shoot a line. The ones that we have in the classroom just shoot an arrow. And now he wants a right bound. So I go to the right side. Do I have to be even with this guy on the left?
No.
No, you just get to the right, people. Don't be crazy. All right, there he is to the right, and he's away from the vertex. So I'll press enter, and now he shoots this. This is how I know it's a guy, because he goes, hey, you want to play a game? No, I don't. I press enter, and he tells me what the answer is. Now, notice this. Look at that crazy number. I couldn't see it this morning. I still can't see it. Tell me what that number says.
2.000019.
Okay, this morning I said 2.999, and the kids turned around and looked at me, and I was like, oh, I told you I couldn't see it. But 2.000019. People, what is that? 2.
That's 2.
It might also say 1.9999997, and you're like, what? What is that?
It's not 2.
That's 2, people. That's 2. Would that be 2 to NASA?
No.
Yes, it would be. People, that way, I mean, they're only carrying it out to probably the 4th or 5th decimal place. It's going to be okay. You're not going to blow something up. Okay? My calculator's a little bit glitchy. Did he get close?
Yeah.
People, he got so close. Okay? So close. Another number that sometimes you see here, watch this. This one always messes kids up. If it was this number right here, you might see. No, never mind. I'm not going to do it right now. Okay, so I'm going to leave it alone. I'll address it later because it really is not going to happen in this case. All right, so there's my vertex. I could check my table, and there's my points, 0, 6, and 1, 0. Okay, so do you see why I'm not letting you use a calculator? If you use a calculator, would you have to know anything?
No.
People, you don't have to know nothing. All right, so that's not what we're doing. All right, so let's put 2 things down on this piece of paper. The maximum and minimum. Now, when I say maximum and minimum, I'm really talking about the what of the parabola?
The vertex.
Yes, this is the vertex. Okay, maximum and minimum. All right, in order for it to be a maximum, how does my parabola have to open? Maximum. Down. It has to open down. Now, in order for it to open down, my quadratic term, notice I'm using a lot of vocabulary here, okay? My quadratic term must be what? Positive or negative? Negative. This is my x squared, guys. Your quadratic term is your x squared. I'm really talking about a, aren't I? Okay? He has to be negative. So a has to be less than 0. In order for it to have a minimum, which is what this is right here, okay, he has to open how?
Open up.
Up, which would make my quadratic term
Positive.
very good, which would make a
Greater than 0.
very good. Do you see all of these things say the same thing, don't they? It's just a different way, but they all say the same thing. All right, anybody got a question? Okay, so would you like for me to give you your worksheet and let you just try one?
Yes.
I gave the other class 10 minutes. I'm going to give you 5 because I don't want to run out of time. Okay,
Oh,
would you like? Yes?
Yeah, sure.
Okay, so let me show you what your worksheet's going to look like. I'm just going to leave it up here and I'm going to pass them out as I'm talking.
That's
Okay?
not bad.
So, ooh, almost tripped. So this is your worksheet. I'm going to want y'all to work number 2, okay? And I'm going to give you 5 minutes. Okay, here's Steven.
Oh, Steven.
And here's y'all. Okay, so I would do 2, all right? I'm gonna say this, you might put a scary face by number 4. Whoa, it'll kick your tail if you're not careful. He's the hardest problem, I think, on the whole dang worksheet,
I got it.
okay? And it is actually not over 4.1 through 4.3, it's only 4.1 through 4.2.
And,
I think that's me.
starting 2021 all strong.
Here you go. Wow, that was good. All right, you got 4 minutes.
Working number 1.
So the negative b is just the
I'm
opposite.
working number 2,
Negative b is the opposite.
opposite of B.
Number 2?
1 doesn't have a B in it, that's why I say skip it. Or actually, yeah, it does, it doesn't have a B.
Number 2 has a B, or number 1 has a B?
That's why I didn't do number 1.
Okay. If you do it in the calculator, you have to put in this. Is it a fraction? I don't think so.
What, how do you know what h is?
You follow the formula? Negative B over 2A.
And then whatever you get is H, is that?
Mhm.
Okay.
And then you have to plug it in to find the K. All right, I'm gonna give you about another minute. Okay, I got the answer up on the board. All I did was put it in the calculator for you, so you kind of get an idea of what. Are we all necessarily gonna pick the same points for our T-chart? No. But over the 900 years that I've been teaching, I have most of the points that people pick, so. should have gotten your vertex to be -1, -5. Is that right? Axis of symmetry is what?
That's a great question.
No. There you go. X equals -1. Y'all listen to me. Look at look at all of this. Do you see every problem on here has axis of symmetry, axis of symmetry, axis of symmetry. Look at the next pages. Axis of symmetry. They're all on there. Every time, if you miss it, that's going to cost you. Okay? So always write it as a line. Don't write it as a number. Anybody got a question? Everybody okay with that? Okay. So now we're moving on. Now, before I move into the next section, I want to show you these at the bottom because we're going to do some like this. All right? So look at this right here. It says, put it in standard form, then follow the above directions. So they gave it to me and it looks different. Okay? I'm going to put this in standard form, put that answer, and then I'm going to answer all those questions and graph it. Take this. I'm going to put it in standard form, and then I'm going to answer all these questions and graph it. All right, so I want to show you an example like each one of these, and then I'll be finished with section 1. Okay, so the first one, I don't know why they're like this, but anyway, example 6. They're kind of out of order. It says write in standard form. Okay, so this is kind of like the number 5 on your worksheet. He looks like this. F of x is equal to 4 times x minus 1 quantity squared plus 9. All right, so now I want to stop for a second and I want to, y'all think I'm chasing a rabbit, okay? But I'm not. I'm fixing to teach you a skill. So here's the deal. I need to square this binomial. And I do not want to go over here to the side of my paper and go x minus 1 times x minus 1 and full that out, okay? Because that would take me entirely too long. So I'm going to teach you how to square a binomial in less than 7 or 8 seconds. Some of y'all will be less than 5 seconds, okay? So, now y'all listen to me. This is an important skill. This happens. You have to square binomials all the time. So I need you to be fast about it, okay? So here's what you're going to do. To square a binomial. What does binomial mean? What does it have? 2 terms. That's right. Like a bicycle. 2 terms. It has an x, and this one has a -1. All right? There's 4 steps, but they're really easy. All right? The first one is you're going to square the first. The second one, you're going to keep the sign. The third one, twice their product. What does product mean? The answer when you what? Multiply. Okay? So twice their product. And the fourth one is you're always plus, square the last. Okay, square the last. All right, so let's do some and let's see how good we can get with this, okay? Are we going to start off doing it in less than 7 seconds? No, we're not, okay? But we're going to get there. All right, so here we go. X minus 5 quantity squared. All right, so are you ready? Square the first. Tell me what you get. X squared. Keep the sign. What's the sign?
Negative.
Yeah, minus. Twice their product. Y'all look, I'm going to write their product on the rainbow. That's what I call it. All right, what's 5 times x? 5x. What's twice that?
10x.
Plus, square the last. What's 5 squared, people? There it is right there. All right, now let me show you where it comes from. What if we fold it? X minus 5 times x minus 5. Full. First comes first. Look, there's my x squared. It's the first thing squared. Okay? Now, look at this. The inners and the outers. The inners, minus 5x, and the outers, minus 5x. How many minus 5x's do you have? two of them. That's why you twice this. You have one from the inners and one from the outers. That's why you have to double it. And then the last, y'all, it doesn't matter what these signs are. When you multiply like signs, you always get a positive. And then 5 times 5 is 5 squared, 25. Okay? You ready for another one? Here we go. X plus 9 quantity squared. You read me the rules and I'll tell you what the answers are. Go.
Square the first.
X squared plus, okay, so their product is 9x, and twice that would be 18x. Come on. Plus 9 squared is 81. There's my answer. Is that easy? Okay, all right, let's try another one. Are you ready? X minus 6 quantity squared. X minus 6 quantity squared. You do it. All right, everybody got it? I squared the first, x squared, kept the sign, minus, twice their product, 6x times 2 is 12x, plus square the last, 36. Yes?
Yes.
Okay, here we go. You ready for another one? All right. X plus 7 quantity squared. 8, 7, 6, 5, 4, 3, 2, 1. Did that make it more difficult when I count?
Yes.
Okay, so it usually puts a little pressure on you, and then you go, oh, and then you, oh, I got this. So square the first, keep the sign, twice the product, plus square the last. Okay, I'm gonna time you again. This one's gonna be harder. Be careful with this one, okay? 5 minus 6y, quantity squared. 5 minus 6y, quantity squared. 8, 7, 6, 5, 4, 3, 2, 1. Okay, the one thing I want you to check is make sure when you square the last that you squared both, the 6 and the y. You can't just square one of them. You have to square everything. Okay? So square the first, 25. Keep the sign, minus. Their product is 30y, and twice that is 60y. Plus, square the last, 36y squared. Y squared. Okay? It's a quadratic, guys. Okay? We're making it a quadratic when we square it. You have to have a squared quantity. Okay? This is called your quadratic term. This is called your linear term, because it's an x to a y to the first, and this is my constant.
Okay,
All right. Ready? One more. This is the last one. Do it well. 2x minus 9y quantity squared. 2x minus 9y quantity squared. All right, time's up. I'm just playing.
Ah.
Do you have to know your multiplication facts? People, you gotta know your multiplication facts. If you don't know them now, you better get the flashcards out. Okay? All right. So square the first, 4x squared. Keep the sign, minus. Twice their product. Their product is 18xy. Y'all look, if this were a test, I would never do that in my head. I would do this, 18xy, and when I double it, I get 36xy. especially when there's a 2 involved, sometimes your brain will go, you already doubled it. You see what I'm saying? So be very careful. Don't make careless mistakes. And then plus 9y squared is 81y squared. All right, everybody okay? Okay, so let's go back and do this problem right here. Now, what is the first step that I should do when I do this problem?
Include the 4?
All right,
No, okay, then
say it again.
What we just did?
Layla, say it. Squared.
Square bar over.
Yeah, you gotta raise to your powers first. Y'all, you cannot distribute the 4, okay? Why? Because you haven't raised to the powers. It's not 4 times x minus 1 and all of that squared. It's 4 times x minus 1 squared. So you have to do this first, all right? So I got 4 times. Well, that's okay, because we can do this in just 5 seconds. So, square the first, keep the sign, twice their product, plus square the last. X squared minus 2x plus 1, and then there's my little plus 9. Now what property am I fixing to use? Distributive property, here, here, and here. All right, so I'll get 4x squared. What's 4 times negative 2x?
Negative 8x.
And 4 times 1?
4.
4. Any like terms?
4 and 9.
Okay, so I'm going to collect these like terms. So 4x squared minus 8x plus 13. So this is what my equation is in standard form. That's what that worksheet's asking you to do. Take this and put it in standard form, okay, and then do all the stuff to it. Now, how do I know that these are exactly alike? Could I use my calculator and let my calculator tell me if those are exactly alike? Tell me a way to do it.
Just put them in and see if they're problems.
If they're right where? Where should the graphs be?
On top.
On top of each other. So I'm going to go to y equals, okay, and I'm going to plug this guy in y1. So 4 open parentheses, x minus 1, close them, square it, and then plus 9. And I'm going to put this guy in y2. Now, like A said, my graphs should be right on top of each other, okay? So 4x squared minus 8x plus 13. Oh, he's barely up there.
No, but it's the second one.
There, he just went over him and turned him red. It was blue and he turned him red. But I don't really like that because I couldn't see it very well. Okay, so I'm going to go to my windows. Who needs changing, X or Y?
Why?
Y. The Y min or the Y max?
Nice.
Yeah, so I'm going to go down here to my Y max and I'm going to make it a 20. Okay, and now I'm going to graph it. Oh, that looks a lot better. There's the first one, and here comes the second one. Right over him and turning red. Okay, so, but this is going by looks, isn't it? Is it safe to go by looks?
Just go to the vertex.
No.
For the vertex.
Go to what?
We would go to look for the vertex, right?
A better way.
Or intercept.
Table.
Or table.
Table. If I go second in table, what am I looking for in this table?
Same.
To see if the.
Yeah, are my Y values the same? Here's the X value for both of them. Are my Y values all the same?
Yep.
Yes, they are. Then those are exactly the same equations, okay? Just a way that you can check if you're at home, all right, and you didn't have someone there. All right, so everybody okay with that? We got one more. This example 5, it's like the other one. It says, again, write in standard form. Y is equal to -2, open parentheses, x plus 5, close them, open them again, x minus 8. Okay, now we're fixing to learn that these two ways that they wrote these things in those crazy ways, those are really important, all right? So, tell me what we're gonna do here. What's the easiest, did I say the only way? No. What's the easiest way to work this problem? To do what? Yeah, to foil it first and then distribute that -2, okay? That's the easiest way. Now let me ask you this. Does that mean that if you did this negative 2 times x plus 5, that you would get the wrong answer? No. So let me ask you this. Would you take this negative 2 and multiply it by x plus 5 and by x minus 8? No. Okay? And here's why. It's a very common mistake. That's why I always bring it up. Because look, if I said, what's 2 times 3 times 4? Would you multiply 2 times 3 and 2 times 4? No, you would never do that. But that's what you're doing when you just, and that's what kids do. They want to distribute. Okay, but there's no plus sign in between there with something all the way. You see what I'm saying? So it is just this number times this is a number and times this number right here. Okay, so be careful that you don't pull it through this guy and through this guy. That's one of the reasons I like to full first. So negative 2 times. Now this guy we're fulling, there's no secret to it. You just have to use the full method. So first times first. What's x times x? X squared. The outers give you a negative 8x, and the inners give you a positive 5x. What's a negative 8x and a positive 5x? Negative 3x. And then last times last, what's 5 times negative 8? Negative 40. Okay? And then, if you distribute the negative 2, you'll see that you get negative 2x squared plus 6x plus 80. Remember, this negative sign is going to change everybody's sign in here. Okay? So be careful and watch that. Now, one of the other kids in the other class asked me, said, Miss Davis, what if you distributed the negative 2 to here and then full? Well, let's do that. If I distribute the negative 2 there, do you agree that I get negative 2x minus 10? Are you with me? Now, if I full this, I should get this. Do you agree? So, first times first, negative 2x squared. Well, that's good. Okay? The outers, negative times negative is a positive 16x. Okay? And inside, inners, negative 10x. So negative 10x and positive 16x makes plus 6x. That's what I got right there. And then last times last gives me a positive 80. And that's what that means. All right, anybody got a question? Okay, so that's all of section 1. All right, did that seem really difficult? No, it's a lot. I mean, it's kind of a lot of stuff, but look at your worksheet. I gave you 6 problems to practice, okay? And I'm telling you, this one right here, you're going to think bad things about me, okay? This guy right here, this number 4, like, I don't know. Even when I did it, I was like, what in the world were you thinking, Billy Gay? This is crazy, all right? So, but I didn't use a calculator, guys, okay? I didn't use a calculator. So, and no decimals. Don't do decimals. You don't see any decimals in this, all right? Don't give me decimals. I want fractions. You need to learn how to work with fractions. All right, so let's move on to 4.2. If this was not bad, then what is 4.2 going to do to make this so bad? All right, so 4.2, we are going to graph quadratics. Well, that's what we've been doing, isn't it? And now, last time we graphed them in what? Does anyone remember? Standard form. So now we're going to do 2 different kinds of forms. Okay, so really what you're doing is you're learning how to graph quadratics 3 different ways. Standard, vertex, and intercept. Okay, and what you're going to learn is that standard is the most difficult. Vertex is, everybody loves vertex. And intercept is useful a lot of times. Okay, so in vertex or intercept form. Okay, so what I'm going to do across the top of my paper right here is I'm going to give you a comparison of all 3 of these different ways. So I'm going to start off with standard, because sometimes it helps to look at something again and compare it to what you're learning. So standard form. Well, standard form is that y is equal to ax squared plus bx plus c. My vertex was hk, right? But what did I have to do? How did I find h?
Negative b to a.
Negative b over 2 times a. okay? Negative b over 2 times a. And how did I find k?
Plug it in.
Yeah. Plug h in. All right? So the next one we're going to talk about is this is the best one, y'all. This is amazing because it's called Vertex Form. Vertex Form. Okay? You know why they call it Vertex Form? People can look at the stinking equation and scream out the vertex. I don't have to do anything. Okay? I can look at it and go, oh, here's the vertex. All right? That was the only hard thing we had to find over here. So everything else should be pretty easy. And I'll tell you this too. On this guy right here, how many points did you have to have on your graph? 5 points. Okay? On this guy right here, 3 points. That's all I want. 3 points. Which means how many am I going to have to find in my T-chart? 1, because you're going to reflect it through. Unless it's some crazy fraction thing, and then I'll just go, oh, I'm finding 1 on the left and 1 on the right. Okay? So this is what vertex form looks like. Y is equal to A. Now this is the same A that this A is. So this A is going to follow all that information that you already know about him. Positive opens up, negative opens down. Bigger than 1 is narrower. Between 0 and 1 is wider. Okay? Then it's going to be x minus h, quantity squared. And then plus k. Okay? Now, I'm gonna point something out to you, okay? Because I'm remembering it. What is this C? When this is in standard form, tell me what this C represents to my graph. He is my y-intercept. Guys, don't mistakenly think this guy is my y-intercept. Okay? Why? Because, do you see that 9 right there? Is that a 9? You see that? That's my y-intercept. It is not this guy right here. Okay? So be careful when it's in standard form. This is not my y-intercept out here. Sometimes kids get mixed up about that. Okay, so still my vertex is HK. People, it's HK. They're staring at you in the formula. Now, we do have something to consider. Look at this guy and look at this guy.
Oh, it's negative 8.
Oh, so this one's negative and this one's positive. So what do I have to do to him? Yeah, you always have to change his sign. Now listen, does that make all the sense in the world? People, if he's with an X, he is an X, and he moves left or right. How? How?
What did you just say?
Come on, come on. If he's with an X, he is an X. That's why he's in the X place, guys. He moves left or right. How? Opposite of what you think. Opposite of what you think. If this is X minus 4, that means it moves 4 to the what? Right. That's that sign change right there. You see that? That's my sign change. Look at this K. Did I change anything about him?
No.
Look at him. He's a Y. How do I know he's not an X? People, he's not with an X. If he's not with an X, he has to be a Y. That may make a little more sense right here for that A, because I kept saying it was a vertical stretch or compression, and I know sometimes you look at it and go, oh, he's with the X. Not really. See, he's not really with the X. He's out here in front. He's a Y. That's why it's a vertical compression or a stretch. All right, so look at the K. Do I change his sign or keep his sign? Keep. Remember what the rules are about Y's. Y's move up or down, how?
As you want.
Just like you think they would. A plus moves up and a minus moves down. Okay? So this is my vertex form. Let's graph one really quick. We're not going to do one on your worksheet because, what time's the bell ring?
3.
Okay, because these are really easy. When I do this one, you're going to be like, what? That was so easy. Like that whole page will probably take you 10, 20 minutes. All right? So graph y is equal to negative 1/4 times the quantity. Anytime I say the word quantity, guys, that means it's going to be in parentheses. X minus 2 squared plus 5. All right? So I'm gonna go over here and I'm gonna draw me a little graph. I'm gonna put me a little T-chart, because I know I'm gonna need him. Okay, how many points am I gonna need? 3 points. Okay, I'm gonna have 3 points on my graph. That's what that means. All right, and then we're gonna start answering some questions. Okay, are you with me? All right, so my first question, does it open up or does it open down?
Down.
Very good. How did you know that?
Oh, because it's less than 1. Oh, it's negative. No.
It's negative. Positives and negatives are what make it open up or down. Positives up, negatives down. So my A is negative, okay, which is gonna make your x squared. Remember, when you square this, then you're gonna multiply that by, and that's gonna give you a negative 1/4 x squared. All right, and so that's gonna make him open down. Is he wider, narrower, or the same?
Wider.
Very good. This 1/4, y'all, he's not with an x. See, he would have to be inside those parentheses, and he's not. He's out here. He is a y. That's why it's a vertical compression. When you compress something, it becomes wider. Okay? Shout out what the vertex is.
It's 2, 5.
It's change the sign, keep the sign. Change the sign, keep the sign. 2, 5.
Oh.
Tell me what my axis of symmetry is.
X equals 2.
Perfect. X equals 2. So let's go over here and graph this guy. Okay? My vertex is 2, 1, 2, 3, 1, 2, 3, 4, 5. 2, 5. My axis of symmetry is x is equal to 2. Okay? I'm going to pick a point. I don't care what you pick. Because this number out here is not extremely big, if it were something like 3 or 4 or something, I would pick 1. Notice that I'm always, y'all, when you pick your points, you're going to pick on one side of the vertex, okay? Don't pick one on this side and one on the other unless your axis of symmetry is a crazy fraction, okay? And I'm always going to go back to the origin because I want to keep my numbers small. Would there be anything wrong with picking a 1? No. I'm going to go a little bit farther out and I'm going to pick a 0. Why? It's going to give me a better idea of what my curve looks like. Okay? So I'm going to pick a 0. If you picked a 1, would I take any points away from you? No, I wouldn't. Okay? So, but I'm going to pick a 0. Is it 5? Is it 0, 5? This number out here.
Yes.
No, people, I told y'all, that is not your y-intercept, okay? Watch, you want me to show you why? Plug that 0 in. What is, look, I'm doing this. I'm going negative 1/4 times 0 minus 2, quantity squared, plus 5. What is 0 minus 2?
Negative 2.
What's negative 2 squared?
Negative
4. Positive 4. Okay? What's 1/4 times 4? What's any number of times is reciprocal, people? 1. And it's negative, okay? And so what's negative 1 plus 5? 4. So at 0, he's 1, 2, 3, 4. I go 2 to get to the axis of symmetry and 2 to get away. And this is my graph. Yep. It's got that 1/4 on him, so you really can see how he's compressed down and it makes him wider. Do I have everything that I need? Yes, I've got 3 points. I used this one and reflected it. I don't have to put my vertex in there. My axis of symmetry is written as a line and not. All right, anybody got a question? Okay, so we got 10 minutes and we're going to do intercept form. Okay, so intercept. Now remember what I said. Sorry, I couldn't talk and spell at the same time. Remember what I said. We're doing the same thing. It's just that what's happening is they're giving me my equations 3 different ways. Was that difficult?
No.
People, that took like 1/4 of the time that the other one took. Okay, it was very easy. So this is my favorite way. But what happens is they're not always going to give it to me that way. All right. So on the test, are they gonna have them all separate like they are on our worksheet? No, that's what makes it difficult, okay? Because they're gonna mix them up. They're not even gonna tell you what there are. They're just gonna say, graph this. You don't have a calculator, so you're gonna go, oh, that's an intercept form, or that's in vertex form, or whatever, okay? So this is what intercept form looks like. Y is equal to A. What do you think, people? That's the same A all the way across here, okay? This time it's X minus P times X minus Q. P and Q are gonna be numbers, okay? So it'll look like something like 2 times X minus 3 times X plus 4, or something like that, okay? Those numbers inside here are my X-intercepts. So my X-intercepts are, watch this, P and Q. What happened to them? What'd you do to them?
You're,
Oh, you flipped the.
I'm flipping that sign. Look there with an X, people. What do you know you're gonna do? You're gonna flip that sign. You see, it's X minus P, but this is not a negative P down here. This is just a P. So on these two guys right here, we're gonna have to always change their signs. Okay? So if this were X plus 1, what would my X-intercept be? Negative 1. If this were X minus 7, what would my X-intercept be? Plus 7. Okay? You're going to kind of like something about this one too. Now, let me show you something. All right? Let's pretend like this is my X-axis. Okay? And here's one of my X-intercepts, and here's the other X-intercept. Are you with me? I got a parabola. I don't care if it opens up or it opens down. It makes no difference. Where is that vertex going to lie with respect to these 2 points?
In the middle.
In the middle. So you're actually trying to find the midpoint between these 2 points. That's a geometry skill. You should have learned that in geometry. Okay? So let's say that you forgot and you don't remember how to do it. Y'all, when you do that, what you do is you make up something that you know. Okay? Let's put some nice pretty numbers in there. Let's say this is a 1 and this is a 5. 1, 2, 3, 4, 5. Do I know where the middle is? People, it better be right here. Okay? It better be right here. So what do I have to do? It's what between? It's how far between? Halfway. So you know you're going to divide by 2. So what do I do with the 1 and the 5? Do I add them or do I subtract them? Because that's the biggest mistake that I get. You add them. Yeah, 5 minus 1 is 4, and 4 divided by 2 is 2, and 2 is not the middle, okay? 5 plus 1 is 6, and 6 divided by 2 is 3, and that is where the middle is, okay? So let me ask you this. How do I find the H coordinate?
you plug in H and find K.
You add P and Q to get the middle.
And do what? Add P and Q and what?
Divide by 2.
Divide by 2. H is equal to P plus Q divided by 2. So how are you going to find K? There you go. Plug H in. All right, so the most common, I've already warned you about the most common mistake. And I've even taught you a way how to know it, okay? The most common mistake is kids forget this, because y'all, this is not going to be on your test. You're going to have to know it. Kids go, oh my gosh, it's that thing divided by 2. Do I add them or subtract them? People, if you don't know, then draw you something out. Draw you a picture that you know the middle and figure out how to get it. Do you add them or subtract them? All right, so let's try some problem. We got about 6 minutes. Here we go. Let's try, whoa, come back. Let's try this problem. I'm going to skip one example and then I'll come back to it. 3 minutes? Oh, crud. Okay. So, example 3. Graph. Yep, that's what we're doing. Y is equal to 2 times x plus 3 times x minus 1. Okay? How many points am I going to need on my graph? 3 points. Y'all watch this. You're going to love this. Say thank you, Miss Davis. So, what are we doing? All right, let's answer a few questions. Does he open up or down? How do you know?
It's positive.
A is positive, very good. Is he wider, narrower, or the same? How do you know?
It's
Greater than-
greater.
He's bigger than 1. Tell me what my X-intercepts are.
3 and -1. -3.
There you go, there you go. -3 and +1. You have to change the signs. Guys, listen to me. If you set x plus 3 equal to 0 and you solve for x, what would x be equal to? -3. If I set x minus 1 equal to 0, look, watch. If I go x plus 3 equals 0, x is equal to -3. X minus 1 is equal to 0. X is equal to +1. Flipping those signs every time. My x-intercepts are -3 and +1. All right, let's find my vertex. Gotta find h. Gotta find h. H is equal to p plus q over 2. What is p? -3 plus q is 1. The order doesn't matter, guys. Okay, it really doesn't matter. Over 2. What's -3 plus 1? -2 over 2?
Is -1.
-1. That's the x coordinate of my vertex. Okay? My vertex is -1. How am I going to find this other guy? I'm going to plug it in. Watch how easy it is to plug it in. 2 times -1 plus 3 times -1 minus 1. What's -1 plus 3? Mm-mm. 2. What's -1 minus 1? All right. How many negatives do I have? 1. So my answer is negative. What's 2 times 2? Times 2 is 8. So -1, -8. All right? So -1, -1, 2, 3, 4, 5, 6, 7, 8. Here it is. -1, -8. Do I already have my 3 points? What? I hope y'all's Parabola looks better than mine. Mine's kind of whompy job. All right. Yeah. All right. So that was almost all of those 2 sections. I'll get the other part, but y'all can do everything on your worksheet. We'll also do some of that Wednesday. Okay? Good job. Welcome back.